Hey Emma. I'm just going to pull a few problems for you to look at, and hopefully that will help. And if you have any questions about anything that's in these videos, just make sure that you email me again and I'll see what I can do to help you out. I know that the distance learning thing is not ideal. I do appreciate that you are giving it some effort though. And also just remember tomorrow between 11 and 11:45, if you have any questions, anytime, it doesn't have to be for the whole entire time. You can kind of pop in and out as you need to. But if you have questions, then you can always hop into that Zoom meeting too if you want to. All right, so first one, let me just draw this here. Sorry, you know that I'm not an artist. I'm just doing my best here. Let's see, so this is 64 up here. This is G, this is H, this is F. And this is 72 down here. Okay, so let me pop over to my doodad over here. Slide this over here. Okay, so you can kind of see that. See if I can zoom in this a little bit. Okay, so you can see that we've got our angle up here. That's our 64 degrees. And then our hypotenuse is X, and then we have another side labeled 72. So first of all, when we talk about trig functions, remember that what we're doing is we're talking basically about similar triangles. And so this is similar to all other triangles that have a 90-degree angle and a 64-degree angle. Okay, and so their ratios are always the same, and that ratio that we use, those are those trig functions. Okay, so let me grab a couple of different colors here so that it's easier for you to kind of see everything that I'm doing here. All right, so the very first thing that you always want to do with the trig functions is you want to start by labeling which angle you're basing everything off of. And so in this case, it's that 64-degree angle up there. And so we're going to call that 64-degree angle theta. I'm going to zoom in just a little bit more here. Okay. Maybe a little bit of a focus too. All right. Okay. Once we know what theta is, we're going to label all the sides of the triangle. Okay. So we always want to start with the hypotenuse, because the hypotenuse is always going to be opposite that 90-degree angle. So turn that little corner into an arrow, and this right here, we'll just label that as our hypotenuse. Okay, and then wherever theta is, when you go to the opposite side there, that's going to be the opposite leg. Okay, so you've got theta, which is opposite the opposite side. You have the hypotenuse, which is opposite the hypotenuse. And then the only other one that we have left then is going to be hold on. That adjacent side. Okay, so also remember that your trig functions are represented by SOHCAHTOA. Okay, so the S stands for sine, O is opposite, H is hypotenuse, C is cosine, adjacent over hypotenuse, and T is tangent, and that's opposite over adjacent. So theta is always going to go with your trig function. Okay, so in this case, what we're talking about is 64. 64 is going to be our theta. Okay. When we look at this drawing, we want the two sides that have been labeled. Okay, whether it's with an X or whether it's with a number. And the one that hasn't been labeled or doesn't have anything with it, we can kind of forget that one. So the one that we can kind of eliminate right now we don't need the adjacent because it doesn't have a length next to it, and it's not the side that we're trying to figure out. We are, however, trying to figure out what the hypotenuse is, and we know what the opposite side is. So we're looking for one of these three trig functions up here that uses h and o, and not necessarily in that order, but just that use those two letters. So if you look up here, well, the first one that we come to, sine, uses opposite over hypotenuse. So the trig function that we're going to use with this right here is going to be sine. So we're going to do sine of 64. And we know that it has to be the opposite over the hypotenuse. Okay? So O is our opposite. And I'm not going to write this in. I'm just going to say O is on the top. So that's this 72 here. And the hypotenuse is the one that's on the bottom. So that would be h. So we have sine of 64 is equal to 72 over h. So I'm going to pull the calculator up here. The very first thing after we set up that, that proportion is we want to figure out what is the sine of 64. That's the first thing that we want to do. So all we have to do is just in your calculator, typically most of them you're going to have to type the number in first, and then you hit that trig function, sine of 64. Whoops, that's not what I wanted to do. I hit it twice. Hold on, let me try that again. 64 sine. Okay, so you can see right here that the sine of 64 is 0.8987940462. Da 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 da. Okay, so my suggestion would be to round to the third decimal place, which means that you have to look at the number that's after it to know what to move this to. So 0.8987 would round to 0.899. Okay, so I'm just going to replace the sine of 64 with 0.899, and I'm going to put that over 1 because we're just going to treat it like a proportion. And then we have 72 over h. Okay, so basically all we did is just substitute for the sine of 64, and all we're going to do now is just solve that proportion. So when you take 72 times 1, you get 72. And when you take 0.899 times h, you get 0.899h. So to solve this equation now, so we've done the cross multiply. Now we just have to do the divide part. So when you do 72 divided by 0.899, you get 80 point, and I believe they were asking for the nearest tenth of a foot. So I'm just going to come back. Yep. If we look at this and recenter, it says to the nearest tenth of a foot. So 80.08 would round to 80.1. So 80.1 is equal to the hypotenuse. Now, here's the thing. I used the right trig function. I used the correct ratio over here. If it tells me that I'm wrong, it's because of a rounding error. Okay? And I don't care about rounding errors. So we're going to say that we want to submit that. Okay. Yep, we were correct. Okay, so let's try another one here. All right. So again, I'm just going to take the time really quick here to set this up and draw it, and then we can kind of check that one out too. All right, so here's the next one. So once again, very first thing we want to do, identify what theta is. Okay, theta is always going to be the angle. So that's going to be this one right here. 38 is going to be our theta. Okay. Now from there, if you just go opposite of theta that's going to tell you the opposite side of that triangle. And again, we can always find the hypotenuse just by looking directly opposite from that 90-degree angle. So here's our hypotenuse right here. And then that means that the x value, that's our adjacent. Okay, so really quick again. Whoops, move those down a little bit here so we can see those a little bit better. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And so one of those three is what we need in order to figure out what x is equal to. So again, look at the three sides that we have here. We're trying to find a. We know what the hypotenuse is. It's this one that we do not need. So we're looking for the trig function up here that uses the hypotenuse and the adjacent. So it's not sine because sine uses the opposite, and it can't be tangent because tangent uses the opposite. So it has to be the cosine, which uses adjacent over hypotenuse. So we're just going to set it up. Cosine. So remember, the trig function and the angle go together always. And theta is 38. So we have the cosine of 38 is equal to, we want to do the adjacent. The adjacent is x. And then over the hypotenuse is 8. So just like this. So again, very first thing that we want to do is we want to figure out what is the cosine of 38. Okay, so the very first step, and again, I'm going to pull that calculator up. Oh, good grief. There we go. All right, so 38, I need to do the cosine, 0.788, and there's nothing after the 8, so it's just going to be 0.788. So here we go, 0.788 is equal to x over 8. Okay, and again, I'm going to treat this like a proportion, so I'm just going to put that over 1. And then all we have to do is cross multiply and divide. So x times 1 is just x. 0.788 times 8. So I'm just going to take this times 8. And that's 6.304. And I don't even have to divide because 1x is the same thing as x. So we just have to figure out what they want us to round to. So again, it looks like we're to the nearest tenth of a foot. So that would be 6.3. And we're good. Let's see. We'll do one last problem. And then I think hopefully you should be okay. And if not, let me know. But again, I just want to show you from that last one. Again. Okay. We had the correct trig function. We had the correct angle measure. And we had the correct ratio over here. Okay. So if we have it set up and we solve it correctly, even if we put it in and delta math says, hey, you're wrong, I can override delta math and say, hold on here, you know. So don't worry about it if you get a lot of them incorrect, especially after this and you feel a little bit more comfortable with it, you should be okay. All right, so last one. Give me a second here to get this one set. All right, here we go. If you want to take a second and just pause this and see if you want to try this one on your own, you're welcome to. Otherwise, if you want to go through it with me, that's fine too. So this is the problem that we're going to do, and I have it ready to go down here. So I already have our trig functions up here that we're going to use. Okay, and again, very first thing that we want to do, find theta. Theta is always going to be either the angle measure that you're finding or the angle measure that's labeled. So there's our theta. And if we go across from theta, that's going to tell us where our opposite side is. So, whoops, set this over a little bit. There's our opposite side. Okay, always opposite from the 90-degree angle. There's our hypotenuse, and that leaves the 4.8 in this case as our adjacent. So if we look at these here, look at the ones that we have, and we look and see which one of those has nothing with it. The opposite is what we're trying to figure out. The adjacent is what we already know. The hypotenuse is the one that doesn't have anything with it, so we don't need the hypotenuse. So we're looking for the trig function that uses the O and the A. So sine is the opposite over the hypotenuse. The cosine has the adjacent and the hypotenuse. So tangent is the one that we're going to use. So we're going to use the trig function for tangent. And our theta was 65 degrees. So we're going to do the tangent of 65 is equal to, and then tangent is opposite over adjacent. So the opposite is x, and the adjacent is 4.8. So this is what you should have set up. Okay. Now from here, if they tell us that we're right or they tell us we're wrong, it's most likely a rounding error. So very first thing we want to do, pop up that calculator, and we want to figure out what the tangent of 65 is. So 65 tangent is that 2.1445, and that 5 is going to bump this 4 up 1, so 2.145. So this right here, 2.145, and again, I'm going to treat this like a proportion, so we're going to put it over 1. And then over here we have x and 4.8. And again, when you solve a proportion, it's just a matter of cross multiply and divide. So x times 1 is just x. And then 2.145 times 4.8. So I'm just going to do times 4.8 over here. 10.2936. That 6 is going to bump this up. So 10.294. And let's go back here and see how we did. And they again want this to the nearest tenth of a foot. So tenth of a foot. This 9 here is going to bump this up. So x is equal to 10.3. There we go. Okay, like I said, if this doesn't help, if you have other questions, please let me know. I can look for some more resources for you. If you need anything else, please don't hesitate to ask. Thanks, Emma.